Okay, this is AP Stats. We're in Chapter 8 in Section 2. So, today we're going to start talking about estimating a population proportion, as 8.1 was estimating a population mean. Okay, now, the things we're going to learn about are conditions for estimating P, constructing a confidence interval for P, putting it all together, and the four-step process of doing that. Choosing the sample size. We're not going to get to all of that today, but that's what is in 8.2. Okay, so these are some of the things. I cannot use yet my PowerPoints at the same time of recording, so I'm using the book. But hopefully soon I will be able to do that. Okay, in Section 8.1, we saw that the confidence interval can be used to estimate an unknown population parameter. We are often interested in estimating the proportion P of some outcome of the population, in the population. So here are some of those. We would estimate what proportion of U.S. adults are unemployed right now. Now, to know that exactly, again, that is not reasonable. What proportion of high school students have cheated on a test? Come on in and sit down, young men. What proportion of pine trees in a national park are infested with beetles? What proportion of college students pray daily? What proportion of the company's laptop batteries last as long as the company's claims? Okay, so now we're going to talk about this next activity, but we're going to do that when we get the whole class back together. But let's talk about what it is first. Okay. So we will have thousands of small plastic beads, at least 2 colors, thermos or a container, and a small cup for sampling, several small bowls. So then you can figure out a way to estimate the number of red beads in the container. Now, here's the thing. In the container, you will not be able to see the red beads because it'll be a dark container. So you will have to figure out how you're going to take a sample, and then we will figure out each step of that. Now, before class, your teacher will prepare a large population of different colored beads and put them into a container that you cannot see inside. Your goal is to estimate the actual proportion of beads in the population that have particular color, and we're going to use red. As a class, discuss how to use the cup provided to get a simple random sample of beads from the container. Think this through carefully because you only get one sample. Now, 2, have one student take a simple random sample of beads. Separate the beads into 2 groups, those that are red and those that aren't. Count the number of beads in each group. Determine a point estimate, right? So think about what a point estimate was when we used mean versus this is talking about population proportion. Okay, for the unknown population proportion, P of red beads in the container. Now for the challenge, each team of 3 or 4, and we'll make a couple of teams. We might just make 3 teams, 2 in each. We'll be given about 10 minutes to find a 90% confidence interval for the parameter P. Be sure to consider any conditions that are required for the methods that you use, okay? And so we will do this we'll compare our results with each other and then how you got where you got. And we will do that on Monday. Okay, but we're going to talk a little bit about this other man's class that did it. Okay, conditions for estimating P. Now, when Mr. Vignolini's class did the beads activity on this page, they got 107 that were red and 144 that were white. So their point estimator is the sample proportion, right? Like when we did sample mean, the point estimator was the sample mean. So this is 107 out of 251. If you add them together, you get the 251. So 0.426, that is the sample proportion, or 42.6%, however you want to say it. Now, we're gonna need to try to set up this confidence interval. And as always, inference is based on sampling distribution from your statistic. If you didn't have a statistic, you wouldn't even know where to start, right? Okay, we have to remember shape, center, and spread. So shape, if the sample size is large enough that both, this is kind of the same thing from before, the amount of successes and the amount of failures, so NP and N times 1 minus P, are at least 10, normal condition, the sampling distribution of P hat then is approximately normal. The center, the mean is P. The center of it will be your point estimator. That is, the sample proportion P hat is an unbiased estimator of the population proportion P. Okay, and then the spread, and how to find the standard deviation for your sample. So we have standard deviation of P hat will be the square root of the proportion, or of the success and failure, P times 1 minus P over N, provided the population is at least 10 times as large as the sample, so the 10% condition. Now, interestingly enough, here we are on the next page. Okay. Well, let's read this first. Okay. So, in practice, of course, we don't know the entire value of P. So that's what's going to happen to us eventually. We're not going to know the standard deviation. We're not going to know the proportion of the population. That is whatever, in this case, a red bead. But we're going to have a statistic, a sample. So we are going to base everything that we estimate off of that. Okay, if we did know that, then we wouldn't need to construct a confidence interval in the first place. We would already know it, right? So we cannot check whether N times P or N times 1 minus P are 10 or greater. In large samples, P hat will be close to P. So therefore, we can replace P by P hat in checking the normal condition. So let's see how the conditions play out for Mr. Vignolini's class. Now, so if all was well and we knew the P, we could find the standard deviation of taking the square root of P times 1 minus P all divided by N. And that would be the standard deviation right there. And then here is the sampling distribution of P hat. Okay, with the mean of P right in the center. All right, let's look at the bead situation. Now, hopefully you guys paid attention to your examples when you did reading. Did everybody do their reading? Did everybody do their homework?
I didn't finish it.
It is due Monday, but I'm asking you if you've done it.
I didn't finish.
You haven't finished it. Okay, but it is due Monday, so get on board. Okay, good. Now, Mr. Vignolini's class wants to construct a confidence interval for the proportion P of red beads in the container. Recall that the class's sample was 107 and red and 144 white. So now, problem, check that the conditions for constructing a confidence interval for P are met. So you're going to have to check, just like before, random, normal, and independent. Okay, those are the conditions to see if we can do this, random, normal, and independent. Now, so there are 3 conditions to check, random. So from the reading, the class took a simple random sample. If they say that in a problem, then it means it is random and it's normal. I'm sorry, not random and it's normal. Simple and it's random. Okay, of 251 beads from the container. Normal. Now, to know that it's normal, we use the approximation for the sampling distribution of P hat. We need both N times P and N times 1 minus P to be at least 10. Since we don't know what the actual proportion is, we have to use P hat. That's all we've got, right? So that would be 251 times your proportion, and that would be 107. So basically you already know this because they've already told you it's 107 and it's 144. But that's how technically you would get it. The number out of how many you took, 251, times your proportion. Well, your proportion is 107 over 251, and the 251's cancel, right? You're left with 107. Same deal over here. N, 251, times 1 minus the proportion. Well, you simplify that, you're going to get 144 over 251 times 251, 144. So it's basically, do you have 10 in each success and failure? Okay. Now, and then finally, independence. Okay. So, since the class sampled without replacement, they need to check the 10% condition. And 10 times 251 is 2,510. Well, Mr. Vignolini reveals that there are 3,000 beads in his container. So, would they be okay? Yes, because they did not take over 10%. But you need at least enough to have 10 in each success and failure. So you kind of have this range that you can get. Okay, well, I already told you that part. So let's look at this check your understanding and talk about that together. Okay? And it is right there. Okay? Now, in each of the following settings, check whether the conditions, we'll check all three no matter what, for calculating a confidence interval for the population proportion are met. Okay, so here we have 1. An AP statistics class at a large high school conducts a survey. They ask the first 100 students to arrive at school, one morning, whether or not they slept at least 8 hours the night before. Only 17 students said yes. So we need to check random, normal, and independent. Okay, so was this a random checking? I mean, did they randomly find their sample? Why do you say no, Tahana?
It's not.
I mean, because not doesn't be
Convenience, right? Is
Yeah, it would be convenience,
yeah.
right? Because not everybody had the same opportunity of being chosen. It was the first 100 people to get there. Now, it could be a few different things. You could be getting there early because you play ball, and it's highly likely you did not get enough sleep, as we are well aware of, right? It could be that you have a study group meeting that morning. I was talking to a young man the other day. He goes to Franklin, I think, Franklin Township, and him and his friends were meeting at 7:10 in the morning because they were doing a study session. I would love to hear that you guys do that. That would be awesome. But you really, 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 really need to, if you want to pass this test or any other AP test, really get focused in on that kind of thing. Study together. You know, may you remember something that you don't remember, and vice versa, and you can work together and help each other. And please do that in college. That'll be very, very helpful. Anyway, I'll quit saying that. I know I say it all the time. So that did not meet the random. This was a convenience sample. Okay, what about the normal? What do you think? How many successes did they have? 17. How many failures then? Mm-hmm. So did they have at least 10 in both? Okay, yes, they did. Now, so now that takes care of the normal. Now, what about independent? Remember what they have to have for independent? You can look back, random, normal, and independent. Look at the beads example on page 486. Independent down there. What's it say that has to meet? 486.
10%.
Mm-hmm. So, do you assume that it's 10%? How many students did they sample? 100. So how many students would have to be in that school? Over 1,000. That's right. And they said in the example that it's a large high school. So if they say it's a large whatever, you can assume that the 10% of the condition is met. But you have to state it. you would have to state there are thousands, well, I'm sorry, looking at the wrong thing. A large high school has more than 10 times 100 or 1,000 students. You have to say that, and the 10% condition is met. Okay, let's look at the next one. A quality control inspector takes a random sample of 25 bags of potato chips from thousands of bags filled in an hour. Of the bags selected, 3 had too much salt. So, random. Were they taken at random? Yes, it says it was. A random sample of 25 bags. Okay. What about normal? Is it normal?
No,
Why not?
because they don't have more than 3 instead of 3 that were too salty or something like that.
Right. So the success was only 3 and the failure was 22, right? So they would, to do that, they would have to make this work, they would have to take more samples. Okay. Is it independent?
Yes,
Why do you think that?
because 250 bags of chips is less than the thousands of bags. of
Right.
chips.
It's less, 250 is less than thousands.
Yeah.
Right. Okay. So now, constructing a confidence interval for P. Okay. So now, we can use the general formula that we've seen before. Statistic plus or minus the critical value. This is what we saw in the last one, right? Times the standard deviation of the statistic. Okay. Now, let's look at the standard deviation of our sample. The sample proportion P hat is the statistic we use for the to estimate P. When the independent condition is met, the standard deviation of the sampling distribution of P hat is, the standard deviation of P hat is, instead of P, you're using P hat. I don't know if you can, I'm sorry. There's P there. The P hats are down here. Since we don't know the value of P, we replace it with the sample proportion P hat. So the square root of P hat times 1 minus P hat over N, N is the number in your sample. Okay, now, some books refer to standard deviation of P hat as the standard error of P hat. Same thing. And to what we call the standard error as the estimated standard error. So, just be careful on wording. Okay. Okay, this quantity is called the standard error of the sampling proportion of P hat. It describes how close the sample proportion P hat will be on average to the population proportion P in repeated simple random samples of size N. So, when the standard deviation of a statistic is estimated from data, the result is called the standard error of this statistic. So, it's different, it's different from the standard deviation. It's called the standard error, or SE, because we're using P hat instead of P. All right? Okay. Now, how do we get the critical value of our confidence interval? Now, this gets into this important part, finding the actual critical value. If the normal condition is met, we can use the normal curve. For the approximate 95 confidence interval in section 8.1, we use a critical value of 2 based on the 68, 95, 99.7 rule of the normal distribution. So we've been using 2, right? 2 times the standard error, 2 times the standard deviation of the sample. Okay, we can get a more accurate critical value from table A or a calculator because it's really, really close, but it's not perfect. As figure 8.8 on the next page shows, the central 95% of the standard normal distribution is marked off by 2 standard points. Z equals the standard, and that little sign means we're talking about the actual critical value. So critical value is going to be more accurate, is 1.96 and negative 1.96 for the opposite side. We use the star to remind you that this is a critical value, not a standardized score that has been calculated from data. To find the level C confidence interval, we need to catch the central area C under the standard normal curve. Here's the example that shows how to get the critical value Z star for a different, or critical value Z, that's really more just accurate to say, for a different confidence level. Okay, now, so I think this is where we're going to finish this page, but I think this is where we stopped after this. What is that mess? I don't know what I did there. Oh, it's probably from the highlighter. Okay, so now, here we have, here's our standard normal curve. We've normalized it, so it's 0 there. And the critical value is 1.96 and negative 1.96, with the area of 0.25 on this side and 0.25 on this side. So that leaves